the phone, cannot go use the stick.
Where I want copy link from. My voice is really good. Check. I don't know how can I send this into person now. Sound check. Hello everyone, and okay, I think I'm live. Hello everybody, and welcome once again to another brief tutorial. And in this tutorial, we are going to continue from, or we're going to start from wherever we stopped previously. I'm just going to start over from the beginning and continue to the end. So concerning what we are doing today, it's pseudocode. All right, so we're talking about pseudocodes. Let me just give me the permission. Let me just make this at the starting point. Show from the beginning. Okay, so from the beginning, so I want to welcome everybody to this training. Welcome each and every one of you that have made it possible to join us today on in today's training. Today we're going to start all over again from where we stopped, and we stopped at pseudocodes, where we tried to explain what pseudocode it's all about. So I said pseudocode is a way of planning and representing code using human readable and structural instructions that resembles programming logic. So pseudocode is just a pattern of planning your code. All right, so let's just picture what we are trying to say. All right, if you want to be a developer, if you want to be a programmer and stuff like that, you need to understand what pseudocode it's all about. And pseudocode is what helps you build your your logical mentality, because it helps you, it guides you in planning and representing your code, just like baby steps before writing code. All right, so before jumping to any programming language, you need to understand what pseudocode is all about. And in this video, I'm going to explain everything that has to do with pseudocode. All right, so pseudocode is a way of planning, representing coding using human readable structural instructions that resemble programming language. So that has been said, it's just a simple way of building your logic sense when it comes to programming. That's what pseudocode is all about. So it's all about teaching you, just like you're teaching a child how to take his first step. That's what pseudocode wants you to do. It's just like programming, but this time it is not on a particular programming language. As simple as that. So that brings us to one of the most popular questions that people ask themselves: why learn pseudocode? As I said earlier, pseudocode makes your code logic clearly. All right, it makes you plan your code logic very well. All right, so with pseudocode, you foresee how you are going to solve problems. So for example, we want to solve problem like that has to do with creating a data or an API or a Cloudflare, or like something like a web or a weather analysis kind of application. So it helps you reason, okay, I'm going to go from this step to this step, from this step to this step. Okay, so for example, if you want to create an algorithm that can know if 2 is greater than 3, all right, so it makes you think, all right, I'm going to start from here and I'm going to end from here, end at that particular place. So this is what pseudocode enables you to do. All right, it gives you that rationality, it boosts your rationality, your logic sense. It encourages you to be a problem solver. All right, it encourages you to be a problem solver. It makes your brain to think out of the box. Now that AI is evolving around the world, and most programmers now use AI. Me too, I use AI to an extent, just as an assistant, just to enable me, fasting my work and all those stuff. All right, but if you are beginning or you're a beginner and you want to go into development, if you want to go into IT, pseudocode, starting with AI rather, we will land you in a very, very catastrophic moment where you cannot defend whatever you're doing. But pseudocode is a primary ground, just like a kid that that entered school and started from JS1. Most people neglect pseudocode, but this is a very important step for you to take, all right? Because it encourages you to solve problems, make you think logically inclined when it comes to programming. All right, it bridges the gap between algorithm and real code. So it doesn't append to a particular programming language. Pseudocode does not only say, okay, pseudocode is a JavaScript programming language. No, if you understand pseudocode, you can code in any language, provided you know the syntax. You can code in any programming language provided you know the syntax. And the other thing I said here, that it is easy to understand. Pseudocode, unlike other programming language, is very, very easy to understand. Okay, it is very clear, it is human readable. If you look at what I stated earlier, I said that pseudocode is a human readable code. Okay. Sorry, 1 minute. Pseudocode is a human readable code, so it does not need for you to. There's no need for you to think like this is a JavaScript syntax and all those kind of things. I think I made that very, very clear. Okay, so there's no relation between a particular programming language, but it gives you the elementary basics that other programming languages are built on. All right, if you understand pseudocode, if you're learning JavaScript, you just need to understand how JavaScript works, and you can easily solve problems with it. All right, so the key features of pseudocode is what I stated that the first thing is what? It's plain English plus logic. All right, it's plain English plus logic. For example, now we want to create an AI model that can turn on, that can know if the environment is hot and turn on the AC, and know that will cool the environment, and know if the environment is hot and turn on the AC that will, and if the environment is cool rather and turn on the AC that will, that will make the environment warm. So what we're going to do now in pseudocode brings you back to logic. So for example, let me come back with what I'm trying to say. If you want to make a programming language that can, or you want to make a program that can, build a kind of system that can condition the atmosphere. For example, if it's cold, it will make it hot, or warm, that will fit into the particular temperature. And if it's warm or if it's hot, it will make it cold. What we're going to do is pseudocode enables you to logically think of it. Just imagine now, if the environment is so and so degree, then the AC should be on when it has to do with the air condition that has to do with cooling the environment. So you can state something like let A be equal to the temperature 40 degrees, okay, and let B be equal to the temperature 20 degrees, because room temperature is 35 degrees to 40 degrees. So if let A be equal to 45 degrees and let B be equal to 20 degrees. As simple as that. So if you want to understand it, let me just show you what I'm trying to say. Okay, just give me a moment. Let me show you what I'm trying to say. So coming to the logic, we want to build a model that can actually predict when to turn on an AC to make the environment cool, or to turn on an AC to make the environment hot. All right, I'm so sorry for being distracted. So first of all, we need to just say, let A be equal to, let me say, 60 degrees. All right, this one we are going to use this thing to monitor if the environment is cool or hot. I'm going to say let B be equal to 20 degrees. So anything below 20 degrees we'll consider it very cool, and we're going to turn on the AC to make it hot. Okay, so we say if, as simple as this, it's just an if and a logical statement. If A is greater than 60 degrees, so we say assume 60 degrees. If A is greater than 60, or let's just make this 50 degrees. Okay, let's just make this 50 degrees. So if A is greater than 50 degrees, then we'll go say turn on the AC. All right, if A is greater than 50 degrees, then we'll say then the AC will be on. Then cooling, let's say cooling will be true, will be equal to true. Or you understand that? Then cooling will be equal to true. But that is what we see. Else, that means it is not greater than 50. Then that means the atmosphere, the cooling condition will need to be, or let us use an else if. Else if, that means if is not this one, that means let us still check for another thing. If the condition is lesser than, if A is lesser than if A is lesser than 50 degrees, that means the atmosphere is normal. We're going to say if A is lesser than 50 degrees, that means the atmosphere is normal, there's nothing there. Alright, it's just normal for a normal person. We say let the condition be off. So the AC should be off. Alright, the air condition should be off. Okay, or the air condition should be at a particular temperature. Okay, but for now we just say the air condition should be off. Alright, so we can just turn off the air condition. But if it's not lesser than 50 degrees, alright, if it's lesser than 50 degrees, the condition there's a little bug here. If A is greater than 50 degrees, then the cooling is true. Else if B rather is greater than 50 degrees, if B is lesser than 20 degrees, let the cooling be false. Alright, you understand? I hope you understand what I'm trying to say. If A is equal to 50 degrees, if A is equal to 50 degrees, is greater than 50 degrees, cooling is equal to true. That means the air condition will turn on for the atmosphere to be cooled. But if B is lesser than 20 degrees, that means cooling should be false. That means there's no need for cooling. Alright, the atmosphere either should be normal. Okay, either the atmosphere will be normal, that means the AC will be off automatically. You understand? That means the AC will be off automatically, or nothing will happen, since is what is this. Alright, so if the air condition or if the atmosphere is higher than 20 degrees or 50 degrees, cooling will take place. That means the AC will be turned on. But if it's not higher than 50 degrees, then to now check if B, that means the thing we are looking for, the variable we are looking for, is lesser than 20 degrees, that means cooling will be off. Okay, that is how I'm just going to show you a simple logic of how this is not about. So if you understand how pseudocode works, you are going to understand very simple what everything is all about when it comes to programming. All right, so it's very user friendly. You can see how simple I just predict this part, explain this particular variable. All right, so if A is equal to 50 degrees, A is equal to 50 degrees, B is equal to 20 degrees, and now we are checking if A is greater than 50 degrees. That means the cooling should be true. That means the atmosphere is hot. That means it needs to be cooled. That means the AC for cooling will need to be turned on. But if it's not up to 50 degrees, that means B is lesser than 20 degrees. Then we'll now check if B is lesser than 20 degrees. Because if B is lesser than 20, if the atmosphere is lesser than 20 degrees, that means it's very, very cool. And then we need to turn on the AC. Alright, and that is how simple this is all about. Okay, I'm just trying to explain this in a very friendly format. Okay, so as simple as that. So let me go back to the slide as normal. All right, so as simple as that. So secondly, there's no syntax rule. It's not tied to any programming language. I said that earlier. It is well indented, followed by structure, all those kind of a thing. All right, so I'm just trying to show you the simple terms of pseudocode. I'm so sorry if I did not explain this part very well. I was very, very distracted. Okay, I was just trying to explain, but in the future, when we're going further, still in this video, I will throw more light to what just happened now. Okay, so moving further, pseudocode features, as I said earlier, they typically use short phrases or keywords to describe steps in pseudocode. All right, so when it comes to pseudocode, we use simple terms and simple steps to describe pseudocode, everything that is in pseudocode. All right, they use simple steps and all those things to describe everything that is in pseudocode. All right, for example, we use the read, write, set, if, else, end if, while, end while, repeat, all of those things. All right, I dropped this particular document on the platform. So what am I trying to explain here? All right, when it comes to pseudocode, there are key factors that we look up to. All right, we have the read, write, set, else, end if, while, end while, repeat, and until. I'm so very sorry. I'm very, very distracted right now. All right, moving forward, there are common pseudocode keywords. All right, this is where when we start pseudocode, this is the main thing that we need to know. There are common pseudocode keywords. Okay, there are common pseudocode keywords. And when it comes to pseudocode, there's going to come the start, the end, the input, the if or else, the for or while, the set or assign, the call or return. Alright, so in pseudocode, everything starts with start and everything ends with end. Okay, so the output, so if you want to start a pseudocode, you make it with just start and then you end it with end. Okay, so you start it with start and then you end it with end. Moving further, there is another thing called input. Input is what we use to take data from the user. All right, so for example, you're filling in, let me use a simple form of an input. You are filling a form online, you put your username and your email. You are simply imputing your username and email. All right, so this is what we use to get data from the user. All right, then the output is what we use to display the result. So start is what we use to begin the code, or begin the algorithm, and then end is what we use to end the algorithm. Input is what we use to get data from the user. Output is what we use to display everything that has to be used. Don't worry, as we're going further, you're going to understand what pseudocode is all about. All right, so if and else is a conditional statement. All right, that's like, if you see what I did at the previous slide, I think, let me just go back a step backward. You can see where I use this if. I use this if for something. I said if A is greater than 50, colon is equal to true. Elif, that means B is lesser than 20. That means if B is lesser than 20, colon is equal to false. All right, so coming back to our code, you can see what this is. If else is trying to do. So it's a conditional statement. Okay, if this is equal to this, let this happen. For example, we want to know if 2 is greater than 3. If 2 is greater than 3, print 2 is greater than 3. Else, print 2 is not greater than 3. That means if it prints 2 is not greater than 3, that means 3 is greater than 2. You understand what I'm trying to say? So between 2 and 3, you're trying to check which one is the bigger number. So you're gonna check. You're gonna use if 2 is greater than 3. Let me just show you what I'm trying to say. All right, with the if else statement. All right, so with this if else, for example, we want to check if 2 is greater than 3. We just say A is equal to 2, and we'll say B is equal to 3. All right, A is equal to 2 and B is equal to 3. So we'll now move further. I'll just use anything I want. I'll say if A is greater than B, then I'll just say print A is greater than B. Print A is greater than B. Else, that means you are trying to say, okay, it's not greater than B. That means maybe something's happened. Then print B is greater than A. As simple as that. So if A is greater than B, print A is greater than B. But if it's not greater than B, print B is greater than A. That is just simply what else is all about. And this is simply a condition. You're just laying a condition. Just like you're trying to propose something. If this is equal to this, then let this happen. Alright. If this is equal to this, then this will happen. That if it does not happen, that means this is not equal to this. Alright. If this is a boy, then is born to wear trousers. He can't wear skirts. Okay. But if it's not a girl, that means he can wear a skirt. Alright, that's as simple as that. Alright, so that is what simply a conditional statement is all about. So like I showed you, that I said earlier, it enables us to start to feel the flow of programming. If you understand this thing very well, you understand what programming is all about. Okay, so coming to the for and while loop. Alright, this is where we used to loop something like an iteration, just like just imagine a rabbit. I don't know how they call it, just like a roller coaster kind of something. It's like a roller coaster. It's continuous, all right, until something breaks it. All right, if you are a boy, keep on running. So since you are a boy, you will keep on running. You understand? That's just simply what a loop is all about. It's an iteration. Iteration, that means a continuous kind of something until it ends. All right, so now there's difference between a for loop and a while loop. A for loop loops over a sequence of things, while a while loop loops while something is actually true. For example, while you are a boy, you will always wear trousers. is a normal statement, alright? So since you're a boy, you will always wear trousers. Until you stop being a boy, that's when you can wear skirts, okay? I don't know if there's any tradition, maybe in Ghana or something like that, maybe boys wear skirt or something, but here in Nigeria, boys don't wear skirt, alright? So while loop, that is just what it's all about. An iteration, a continuous format. It makes something a continuous tense. That is where if you want to make your system go cuckoo, you can just while loop something. Let me say if if 1 is equal to 2, then 1 plus plus. That means if 1 is equal to 1, then 1 plus plus. Okay? So as far as 1 is equal to 1, 1 will be adding 1 itself. You understand? Till 1 is no longer equal to 1. As simple as that. Alright? Then the for loop loops till a particular thing happens, a sequence of something. For example, you want to state that if, let me say, a is equal to 32, you now said, and for a in 32, for a, then I will say, let me say for a in, let me give another variable here. B is equal to a variable. This is simply a variable. What carries a value is called a variable. As simple as that. Don't be confused when I mean variable. Anything that carries a value is a variable. Alright. So as simple as that. So let me say B is equal to 21. So we can say for A in 32. I'm looking for something very much more better. Okay, let me do something else. For I in A, print A. Print A. Alright, so I is nothing, and we are trying to print A. So for I in A, print A. We are simply just calling a variable. For this variable in this thing, just like saying, let I be A. Just like you're trying to say let I be A, it's as simple as that, okay? So for I in A, print A. So it will now print 32. That is the answer that will come out. So that's how simple just for loop is. For loop is just something like sequentially loop something. So meanwhile, while loop is just like while through. If I just say while through, and then I say 1 plus 1, 1 is equal to 1. Now say just like that. While through 1 is equal to 1. You understand? Or I can say while A is equal to 32. I will now say while A is equal to 32, I will say B will be equal to B plus 2. Alright. So while A is equal to 32, B will be equal to B plus 2. As simple as that. So while A is equal to 32, B will be equal to B plus 2. So what this simply means is while A is equal to 32, B will be adding. That means the T will not stop. Alright, I'm so sorry for, I don't know that the thing was not actually showing right now. Alright, so it's gonna show after now, okay? So I'm very sorry for the blankness that just happened right now. I was really concentrated on doing that, and the person that's supposed to All right, so my bad. So as simple as that. I'm so sorry for the screen that is blank. Okay, for the screen that is blank, I'm very sorry for that. All right, so coming back to what we're trying to say, let me start from this particular phrase. I said there are common keywords when it comes to pseudocode. All right, we have the start, we have the end, we have the input, we have the output, we have the if and else if, and we have the for loop, we have the set and assign, we have the call, and we have the return. The start, when it comes to pseudocode, start is what you use to start the code. So if you want to start any pseudocode, you need to declare the start variable. And if when you want to declare the start keyword, and if you want to end the pseudocode, you declare it by saying end. All right, and input is simply what you use to get data from the user, while output is simply what you use to display data to the user. Then if and else if is simply a conditional. All right, so I stated something here. I said if a is equal to 2 and b is equal to 3, and I said a is greater than that. Sorry, my bad. If a is equal to 2 and b is equal to 3, and I'm using this if statement, and I said if a is greater than b, print a is greater than b, else print b is greater than a. So a is equal to 2 and b is equal to 3. What we are going to do now, we are going to find out if 2 is actually greater than b or 3 is greater than 2. So we'll give them a variable. So if a is equal to 2 and b is equal to 3, you can say if a is equal, my bad, I'm distracted right now. We can say if a is greater than b, we can say a is greater than b, else b is greater than a. As simple as that. So it is very simple. If you just look at what I was trying to do here, I'm so very sorry for the distraction. My brain is not really set for this. All right, so coming back to while loop that we're trying to break down, I said while loop is something we use for iteration. All right, to iterate or loop over a particular thing. You're like a looping system, like a roller coaster kind of thing, that continues until something happens. All right, so we said a is equal to 32 and b is equal to 2. We now stated that while a is equal to 32, we say b will be equal to b plus 2. This simply means that while a is equal to 32, which is true, b will be equal to b plus 2. B will now be equal to b plus 2, and in this sense, this b here is 21. So 21 plus 2 will now be still equal to b. You understand? So let me just make it more clearer. Let me don't use b is equal to 2. 3 is equal to b is equal to 3 plus 2. Okay, 3 plus 2. Okay, so as simple as they say, while a is equal to 32, b will be equal to 3 plus 2. So continuously, b will be equal to 3 plus 2. But when I put this b here before, what this actually means that b will be something like 21 plus 2. So 21 plus 2. So while a is equal to 32, so constantly a is 32, b will be adding 2 to 21. So when 2 add to 21, it will be 23. Okay, and still yet a is equal to 32. That means b will now still add to and 2 will now be still add to b, and that means it will now be what? 25. A is still 32. B will now 2 will be added to b, which is what? 27, and continuously just like that. So it will not be an iteration, just like you are adding constantly while something is constant. Okay, as simple as that. I don't know if you are trying to understand what I'm trying to say. I believe it's showing right now. I believe it's showing right now. Okay, so that is just simply what this is all about. Okay, so